Hello friends, today we will going to discuss about API mechanical seal flushing plant 53C. But before going to the main topic, I want to discuss with you a practical scenario. And the scenario is your pump is running perfectly fine with a barrier liquid sealing plant, maybe 53A or 53B. And all of a sudden, your seal got failed and subsequently your plant gets shut down, production loss. And when you investigate that particular seal failure problem, what you find? You will find that the stopping box pressure is fluctuating, maybe increasing, and your API plant 53B or 53A could not handle this fluctuation. So, what is the solution? Solution is plant 53C. So, today we will going to discuss about plant 53C, why plant 53A or 53B fail with a varies stopping box pressure, and 53C is the ultimate solution for your seal system. That is the main discussion point. Now, in 53A, we maintain the barrier liquid pressure with the help of nitrogen. We fill up or pressurize the barrier liquid with the help of nitrogen in seal pot. In 53B, we fill up the bladder with a preset value 70 to 80% of your stopping box pressure. But in both the cases, plant 53A or 53B, we maintain the pressure according to our stopping box pressure, a definite preset value. But if the stopping box pressure varies, maybe increase, your plant 53A or B will not able to increase the barrier liquid pressure. That's why your seal got failed. Now in 53C, how this is maintain the barrier liquid pressure according to your desire, that is the main point. In 53C, we take a tapping from the stopping box. From the stopping box, we take a tapping. This is the tapping, and we put it bottom of the cylinder. In plant 53C, with the help of piston cylinder arrangement, we maintain the pressure. Bottom of the cylinder, we put a tapping, stopping box tapping, and from top of the cylinder, we take a barrier liquid tapping. Before startup of the system, we isolate the pump from the process liquid. We maintain or fill up the cylinder, entire line, sealing system, entire loop, cooler with your barrier. Now you line up the pump and your pump will get pressurized, your stopping box will get pressurized, and this pressure come to the cylinder. Now the question is how this pressure will help to maintain the barrier liquid pressure more than stopping box pressure. That is the primary thing of a physics force balance. In that particular system, bottom side of the piston and top side of the piston force should be balanced. Then only this piston will be in a steady state condition. Now, at the bottom, what is the force? We know force is equals to pressure into area. So, in the bottom side, what is the force? That force is equals to stopping box pressure into area of the piston area AP, and that should be equals to the barrier liquid pressure barrier liquid into the area. What is the area at top side? That is area of the piston minus the rod area. That means area of the piston AP minus AR. Now, what is the barrier liquid pressure? PB should be is equals to P stopping box into AP by AP minus AR. And AP by AP minus AR, this ratio should be always greater than 1. And how much pressure you needed over barrier liquid pressure, accordingly you should maintain this ratio. Suppose we maintain this ratio is 1.4. So if your stuffing box pressure is 5 kg, so burial liquid pressure, what will be the burial liquid pressure? Burial liquid pressure equals to stuffing box pressure 5 kg into 1.4. That means 7 kg. If stuffing box pressure is varies, it reach at 6 kg. What will be your burial liquid pressure? Burial liquid pressure PV is equals to 1.4 into 6. That is 8.4. So that is the mechanism. With this help of this piston cylinder arrangement, we always maintain a burial liquid pressure more than your stuffing box pressure. And that is the beauty of the plant 53C, where your stuffing box pressure is varies. We should always use plant 53C. Now, at the time of walkthrough, what point you should check? We should check the cooling water inlet, cooling water supply and cooling water return line temperature, burial liquid inlet and burial liquid outlet temperature. We should look the pressure gauge reading. The burial liquid pressure, it should be more than the stuffing box pressure, and we monitor the gauge reading, level gauge reading of this piston, because when your seal fail, this piston should move upward. Why? Because this liquid will lose. You lose the liquid, then stuffing box pressurize this piston and piston moves upward. So when this piston moves upward, that means your seal is leaking. In case of primary seal leak or secondary seal leak, piston always move upward. So in day-to-day work through monitoring, you should monitor the level gauge reading of that particular piston rod, and that is the main point. Second thing, your burial liquid should be compatible with your process gas liquid. Friends, if you find this video is helpful, please hit the like button and subscribe my channel to get more technical video in an innovative way. See you in the next video. Bye bye.